So in this problem, we have a database describing 100 examples of printer failure. So I have this universal space. So think of this as my universal space that has all the printer failures. So this omega is of size 100, and there are these 100 printer failures that have been documented in this omega. Of these, 75 examples are hardware failures. So if I were to kind of divide this universal space into two halves, where this piece in orange is those where the printer failure is due to hardware, and that happens to be 75 of them. There's 75 printers that have failed due to hardware related issues, and there are 25 that have failed due to driver related issue. So this is 25, and we can see that there is no overlap between H and D. They're completely disjoint over here. So when I add them up, I get back the entire size of the universal space. So 75 plus 25 gives you back 100. Now, of the hardware failures, 15 had of the hardware failures. So now, if I restrict myself only to this H over here, so within this H over here, of the hardware failures, 15 had Windows operating system, and of the driver failures, 15 had Windows operating system as well. So first thing what we'll do is we'll write this in terms of probability. So I'm going to write the probability of P of H is 75 over 100, right? The probability of H happening from this entire universal space, that's my entire universal space in yellow, is 75 over 100. The probability of the driver happening, the failure related to driver, is 25 over 100. Okay, now if you read the question over here, the question tells you of the hardware failures. Now, if I restrict myself only within the region, excuse me, of the hardware failures, 15 of them had a Windows operating system related issue. So the probability of being a Windows operating system, given that I'm only looking at H's here. Now, because when I'm conditioning on H here, I've automatically restricted myself only in this orange piece here. My entire sample space has reduced from omega to H, right? It has reduced from omega to H, and because of the reduction, the probability of W happening is 15 over 75. So within these 75 machines over here, 15 had a Windows operating system, and the probability of the Windows operating system given only on this D here, only on that D there, is going to be equal to 15 over 25. Okay, so so think of this W as some kind of a region over here, okay, which kind of overlaps. So this could be W over here, Windows. So these machines over here, which is the shaded component of blue, okay, this piece over here, the entire shaded region over here is the think of this as representing the probability. Now, if I think of this in terms of the entire universal space, so this probability is this entire shaded region is a probability of W and H here. Okay. However, I can also think of it a little slightly differently. The entire same blue region can also be thought of that if I were to reduce my sample space, if I assume that H has already happened, and because H has already happened is this piece over here that has already happened. Now within that entire new reduced sample space, okay, this piece can be thought of as the probability of W given H. Okay, so the probability of W given H is only when the sample space has reduced. It has reduced to indicate now only looking at those printer failures where the printer failures have been documented as a hardware failure. Okay, and this is telling you I'm looking at the entire universal space. All right, and likewise, if I were to do the same thing over here, this piece over here is telling you the probability of D and windows happening. Now again, when I look at the entire universal space, when I say entire universal space, from all the 100 printers, this is the probability of D and W happening. Okay, which is this piece over here, D and W. However, I can also think of this. Also think of this region as the probability of actually W happening, given that D has already happened. So if I say, all right, now within these 25 printers, I'm only looking within those 25 printers. If I only look within those 25 printers and I completely ignore the other 75 printers, then I can think of this yellow region as the probability of the failures given due to Windows. Okay, so Windows related probability of W given that D has already happened. Okay. So given that, and because this is such a key principle here, I'm just going to kind of just write it in words here. So this is on the entire sample space, on the entire sample space. And I mean, when I said on entire sample space, it means the probability of W and H happening when I look at all the 100 printers. This is when I look at all the 100 printers here. Here I'm saying, all right, what's the probability of W happening given H, meaning I'm only looking at a reduced sample space, meaning of these 75 printers, what is the probability of them being Windows? Okay, and likewise over here, this piece over here tells you on the entire sample space. This is on the entire sample space, which is of all the 100 printers, which one of those are D and W. Okay, and this is on the reduced sample space, meaning now if I restrict myself only on the 25 printers, only on this rectangle here, which is D, within these 25 printers, how many of them are Windows related? So this is on the reduced sample space. Okay, of 25 printers, this is on the reduced sample space. 25 printers, this is on the entire sample space, meaning this is on the entire, all the 100 printers here, and this is also on the entire 100 printers, because size of my omega is 100. Okay, so first question here is calculate the probability of Windows given hardware. Well, it's already over here. We already have the data right here of Windows given hardware, which is 15/75. Calculate P of driver given Windows. So I want to find out what is the probability of W given D, and this is nothing but, again from lecture, what we know is that this is nothing but the probability, the joint probability distribution of W and D over P of D. And again, from lecture what we know is, I'm going to put this on the side here, which is that the probability of W and D can be written in two ways. I can either write it as probability of D times probability of W given D, which is also equal to probability of W times probability of D given W. These both will give you, both of them are completely equal, and they both give you the joint probability distribution of W and D. So what I'm going to do here is I'm going to rewrite the numerator. I'm going to rewrite the numerator using this piece here. Okay, some probability distribution of W and D using this piece over here. Okay, so that's equal to P of, and again there's a slight typo here. The question is asking us what is probability of driver given Windows. So this is driver given Windows. Okay, so probability of driver given Windows is the joint probability distribution of W and D over P of D, which is equal to P of D times P of W given D over P of D. Okay, now what is P of D here? Well, P of D, this piece over here is already given to us. This is already given to us, which is right there. It's 25/100. So this is 25 over 100. The probability of W given D. The probability of W given D is also given over here as 15 over 25. This is 15 over 25. And the probability of P of D, the probability of D is also given to us, which is this is again, this is should be W. This is W. Okay, so probability of W. Well, probability of W is this entire piece over here, which is this shaded region in blue plus the shaded region in yellow, because the two when I add the two together gives me the entire blue circle, which is W. So P of W is equal to the shaded region in blue, which is nothing but P of W and H plus the region in yellow, which is P of D and W. Okay, now P of W, what is P of W and H here? Well, probability of W and H is nothing but the entire piece of the numerator here, which is so let's do this. Let's rewrite this as W and H, because that's something that we still need to find out. But this piece, which is P of D and W, this piece over here, P of D and W, is this entire piece on the numerator, which is 25 over 100 times 15 over 25. So this piece is 15 over 25 times 25 over 100 plus. What is probability of W and H happening? Well, the probability of W and H happening is nothing but the probability is the probability. So I'm going to take let's rewrite this in a different color here. So we'll take this piece over here, this box in blue, which is nothing but the probability is the probability of H happening times the probability of W given H. Okay, so the joint probability distribution of W and H is nothing but the probability of H happening times probability of W given H. What's the probability of H happening? The probability of H happening is 75 over 100 times the probability of W given H. W given H is 15 over 75. Okay, so this 75 and 75 gets cancelled off, and over here I can cancel out this 25 and this 25 over here, and then what I have over here is 15 over 100 plus 15 over 100. That gives you 30 over 100. So this denominator over here, is now equal to 15 over 100. Now on the numerator I had 25 over 100 times 15 over 25, which 25 and 25 cancels off, and what I have over here is so let's just rewrite it this way slightly. Let's get some space over here. So on the numerator I've got 25 over 100 times 15 over 25, and on the denominator I've got here 30 over 100. Okay, so that's my denominator, that's my numerator. I'm just going to do it like a little bit more cleanly over here. So 25 and 25 cancels off. On the numerator I've got 15 over 100, denominator I've got 30 over 100, and that gives you 1 over 2. So the probability of D given W is actually 1/2.